Alright, I'm gonna try to finish part A in this video. Okay, so I was at question 23. Let's see what this is. So here's a table. There's some x's and values of f prime of x. Here's g of x. We recognize it. Function defined with an integral, or sometimes called the accumulation function. Okay, okay, table above. Okay, on the interval 1, 7, f prime is continuous, has only 3 zeros, so f prime has only 3 zeros. Okay, for which value of x does g have a point of inflection? So here again, the question is about the point of inflection of g. So what I want to do is derive it. We know that that's a fundamental theorem of calculus. Now I would have to study where where the derivative is increasing or decreasing, and to do that it's even better to derive it the second time. So instead of studying where g prime increases or decreases, we're going to study where g second is positive or negative, right? Alright, then we also have g second of x equals 0 at x equals, let's see, 2. I'm looking at the table, right? It's f prime, right? G second is f prime, so 2, 4, and 6. But you see at 4 right here, you notice something? At 4 there is no sign change, meaning what? Meaning g second stays negative. G second stays negative on either side of 4. That means g is concave down on either side of 4, so this is not an inflection point. So it's only at 2 and 6, therefore the answer should be D. Okay, 24. F is not a continuous, f is a continuous function on the closed interval AB. Which of the following statements are not necessarily true? F has a minimum and f has a maximum. Well, we know this is true no matter what f is. If it is continuous on a closed interval, it will have an absolute max and an absolute mean. This is one of the early theorem we looked at this year. It doesn't matter how you do it. Look, you can look at it like that. You know, it may go like this. Here, let me do another one. It may go like that. It may go from, you know, it can be a straight line, right? A straight line is continuous. It can go like this. Okay, it will have an absolute max and an absolute mean. So 1 and 2 are true. F prime of c equals 0 for some c. No, this is not true actually. Look at this one right here. There's no f prime of c is never 0 for any c in the whole interval, right? So I would say 1 and 2 are true and 3 is not true. So not necessarily true, that 3. So it's C, not necessarily true. Okay, that was actually 25. Sorry, did I miss one? That was 25. Yes, I missed 24. Sorry. So I'm going to do 24 now. 24. What is this about? They're giving me a function. F of x is x to the negative 1/3. We know what that is, right? If you want to rewrite it like that, it's this. I don't know if we'll need that or not. What is the derivative of the inverse of f? For this one, I think the easiest thing right here would just be, there's a formula, right? Like, there's a formula that deals with the inverse of f prime equals, do you remember it? I don't right away. I could find it, but I'm not interested actually, because I think this function, to answer it, it's much quicker just to find the inverse actually, right? You know, the first step is you switch x and y. X equals 1 over the cube root of y. Second step, you solve for for y, right? So cube both sides right here, cube both sides, solve for y, and you find x, go right here, x cubed equals 1 over y, and so y equals 1 over x cubed, and this is actually my f inverse, right? I don't care about writing it, don't forget this is multiple choice. Let me just get y prime right away. Y prime, so this is x to the negative 3, so it is negative 3 x to the negative 4, and that is E right away. You see, it's pretty straightforward. Again, we could have gone with the formula, but it would have been a little bit too cumbersome. I'm not a fan of the formula. If I can avoid it, I'll avoid it. I'm not a fan of this one. I did 25, 26. So actually 26, I did prepare this one. So let me see. Let me copy the snip and paste the snip right here. Let me see, can I just paste it there? Okay, here we go. So let's paste it here. Paste. Okay, that's too big. Could have prepared that, but I wasn't sure where it would go on the page. Where am I? Right here. Let me make it smaller. Okay, this is not, let me also text from right here. This is not a difficult question. You don't have a lot of option here actually. They're giving you, this is number 26. They're giving you various possible solution. Well, I mean, come on, this is not gonna work, right? It's not tangent right here, that's A. This is not going to work either. I mean, it's not tangent anywhere right here. Let's see, this is not gonna work, right? D is not going to work either. Okay, so what do we have? What do we have? We have either C or E. There are the only two possibility, okay? C or E. Now, we need to make a difference. It's quite possible that both of them would work. Quite possible that both of them would work. Let me look at it. Yeah, kind of, you know, it goes like that. It goes like that. It goes like that. And then it goes like that. You see the slope field? It's like that. Alright, so C or E. So which one? These are the only two shapes. Well, if you look at C, look at E right here. The slope around here, if you look at E, the function E goes down, right? So you won't have the function that goes like that, right? So this is not tangent right here, right? This line element is not tangent to the graph. So it can be E, therefore it's C. And actually C is the one I almost drew right here, right? If you look at it, C, it's gonna go something at 1, it's right here. You gotta turn right away, and then it goes down, you know, tangent, and right here it slopes back up, and right here. So that's the answer is C. Okay, C right here. Two more questions on this part. A volume of a cube. So let me draw the cube right here. Small cube, sorry. Volume of the cube is, no, not the volume. The volume of the cube is increasing at the rate. So V, and it's a function of the time, right? V is x cubed. Be careful, x is a function of the time, right? Okay, so I don't want to write V prime, because this, you like, what is this? Is this dv dx or dv dt? Well, I'm talking about dv dt, okay? So I'm going to write dv dt. I'm going to use this notation. dv dt is 3x squared times dx dt, right? This is related rate problem, okay? Okay, what do they want? How fast in square centimeters per second is the surface of the area of the cube increasing? So what's the surface of the cube? Again, it's going to be a function of the time. It's 6 times one surface, so it's 6 times x, which is a function of time, x squared. So let's get ds dt. ds dt is, so 6 times 2, 12. Reduce the power by 1 and derive the inside function, which is x of t. So it's dx dt. Okay. I don't know dx dt, right? But right here, what do you get from this one? You know dv dt. dv dt is 20. So you get that dx dt is 20 divided by 3x squared, right? Right, 20 divided by 3x squared. And that's it. So let me rewrite that. So I have 12 times x of t. Let me just write x, because I wrote the x right here. It's the same, x of t. We just have to be aware that it's x of t. 12 times x times 20 divided by 3x squared. So 12 by 3, 4. 3 by 3, 1. And then this x goes with this one. And so we finally have 4 times 20 over x, which is 80 over x. Okay, so 80 over x, ds dt is 80 over x centimeter square per second, and they want us to find that when the edge of the cube is 10 centimeters. So that would be 80 over 10, which is 8, which is E. E. Answer is E. Okay, 28. That's it. That's the last question of the part A. Part A. Oh, that's a differential equation, right? dy dx equals x over y, and the initial condition is that y of 3 equals 4. Okay, only one technique we've studied, separation of variable. Let's do it, and we're done after that with this part. So we got y times dy dx equals x times, sorry, I separate the variable, so I multiply it by dx also. So it's y times dx, dy, sorry, equals x times dx. Alright, so now let's integrate both sides. So we have 1/2 of y squared equals 1/2 of x squared plus c. Then we multiply everything by 2. So you get y squared equals x squared plus 2c, but you know that 2c, c, same deal, it's just c right there. And so we have y squared minus x squared equals c. Initial condition, of course, this is the x and that's the y, right? So if y is 4, so we get 16 minus 9 equals c, so c is 7, and the equation is just y squared minus x squared equals 7, and that's A, right? It's x squared minus y squared equals -7. That's A. They multiply both sides by -1. Okay, we're done with part A.